3:12 a.m. Strait of Hormuz. On board an Arleigh Burke-class destroyer enforcing the blockade, the radar suddenly erupts with a red alert. Dozens of high-speed contacts are racing in from several directions at once, moving like a swarm of furious bees closing in on a hornet's nest. Iran has just launched a coordinated swarm operation. In only 90 seconds, dozens of IRGC fast boats will be close enough to bring their rocket systems into range. Can the U.S. Navy respond in time, or is the Strait of Hormuz about to become the most dangerous waterway on Earth? The geopolitical order has been shaken to its core after diplomatic channels completely broke down. Washington's maximum pressure campaign has pushed Tehran into a corner. In a last attempt to regain control, the Islamic Revolutionary Guard Corps has launched Operation Hormuz Gatekeeper. Their objective is clear: establish total control over the world's most important maritime choke point. Iran is no longer simply making threats. It is demanding passage payments and warning that any Western oil tanker attempting to challenge its control will face severe consequences. 3:20 a.m. At the center of the crisis is an Arleigh Burke Flight 3 class destroyer, a $2 billion masterpiece of American naval engineering built by Lockheed Martin. But this warship is not operating alone. High above the clouds, Boeing's all-seeing eye, the P-8A Poseidon, serves as the U.S. Navy's premier C-4ISR command and control hub. It continuously transmits mapping data to the fleet, giving commanders a real-time picture of the battle space. The P-8A Poseidon identifies mobile launcher units along the coast and a group of high-speed boats leaving their concealed positions. A reconnaissance perimeter is immediately established. At the same time, an MH-60R Seahawk helicopter lifts off, deploying sonar buoys and detection equipment to search for acoustic mines hidden beneath the dark, unsettled water. 3:30 a.m. Over the Strait of Hormuz, the digital fog of the battlefield grows thicker. The P-8A Poseidon shifts from passive monitoring to direct coordination. Its crew deploys a network of AN/SSQ-53G sonobuoys. Originally designed for anti-submarine operations, these sensors are quickly recalibrated to track the acoustic signatures of IRGC speedboat engines through the turbulence of the waves. A highly detailed real-time digital map is created, pinpointing the movement of the Iranian fleet with extreme precision. That data is encrypted and instantly transmitted to the fleet through the Link 16 system. 3:35 a.m. Using this intelligence, the MH-60R Seahawk moves along the edge of the combat zone and carries out the first direct engagement from a distance of 8 kilometers, safely beyond the reach of Iran's 12.7mm machine guns. Through its MTS electro-optical targeting system, the crew locks onto the command boats. Two AGM-114 Hellfire missiles streak through the night, leaving bright trails behind them. Guided by laser targeting, they hit the lead vessels with precision, disabling key command assets in a burst of fire and metal. The IRGC formation begins to lose coordination. With its command element damaged, communication between the smaller boats starts to break down. 3:40 a.m. The IRGC responds immediately with an asymmetric countermeasure. An electronic barrier rises across the battle space as hundreds of Ababel decoy drones are launched from concealed coastal positions, flooding the Arleigh Burke-class destroyer's AN/SPY-6 radar picture with false targets. The original 50 targets suddenly multiplied into nearly 500 flickering signals across the radar screen. The Aegis combat system struggled to separate real threats from decoys as the display filled with metallic clutter and intense electronic interference. At the same moment, Fajr 5 rocket systems positioned on the coastal cliffs opened up with a coordinated saturation pattern. But they were not aiming directly at the destroyer. Instead, hundreds of projectiles were sent into the water around the U.S. warship in a calculated grid formation. Seconds later, huge 15-meter columns of water erupted around the vessel, creating a continuous wall of saltwater spray and steam. The entire ship was wrapped in a moving curtain of mist, blinding infrared sensors and disrupting laser rangefinders. It was a tactical screen designed to overwhelm both human operators and advanced targeting systems, forcing the U.S. crew to navigate a chaotic mix of digital noise and physical obstruction. 3:47 a.m. The battle reached its most intense phase as Iranian coastal units began locking onto the U.S. fleet. The Arleigh Burke-class destroyer immediately initiated SEAD operations. Using coordinates provided by the P-8A Poseidon, the Mark 41 vertical launch system released a salvo of precision-guided interceptors. The coastal launch positions were neutralized the moment they exposed themselves on radar. At the same time, the SLQ-32 electronic warfare system activated at full power, sending a concentrated electronic pulse toward the IRGC's coastal radar network. The signal overwhelmed their receivers and disrupted their ability to track the U.S. formation. The combined precision strike and electronic warfare response created a temporary gap along the Iranian coastline, a narrow window the U.S. Navy had been waiting for. 3:50 a.m. With the main air bases tied up by long-range interception missions, a pair of A-10C Thunderbolt IIs from Al Dhafra Air Base were urgently sent into the fight. These warthogs had been specifically trained for swarm control scenarios. Unlike supersonic fighters, the A-10 can hold a steady low-speed approach at around 300 knots. Paired with the Sniper Advanced Targeting Pod and night vision systems, it becomes a patient hunter, built to track fast-moving boats across the dark, open sea. 3:55 a.m. Exploiting the brief opening in the coastal defense network, the two warthogs dropped through the cloud cover and descended toward the shoreline. To avoid early detection, they followed the rugged terrain of the Iranian coast, weaving between steep limestone cliffs nearly 150 meters high. Staying beneath the radar horizon, they used the mountains and coastal ridges as cover. Then, without warning, they appeared just 30 meters above the water, their wings cutting through the mist rising from the waves. The sudden roar of their engines sent confusion through the IRGC positions below. Inside the cockpit, the A-10 pilots faced portable air defense launches and unmanned strike craft rushing toward their flight path. Every second demanded perfect control. 4 a.m. The night sky lit up with tracer lines, defensive flares, and electronic countermeasures. The American pilots pulled extreme 7G turns just above the surface of the water, fighting the pressure as their vision narrowed and their bodies strained under the force. They had only one objective: stay airborne long enough to break the swarm before it could close in on the fleet. They continued releasing chains of magnesium heat-seeking decoys, each one burning at nearly 2,000 degrees Fahrenheit. Blinding flashes lit up the night and reflected across the pitch-black surface of the sea. In the middle of the chaos, the A-10 formation steadied itself. The pilots brought their targets into view through their HUD displays, and then the GAU-8 Avenger cannon came alive. Its unmistakable roar cut through the night, overpowering even the sound of the waves below. Every second, dozens of 30mm rounds tore across the water, smashing through the fast boat formation and leaving behind burning wreckage, broken hulls, and long trails of oil spreading across the surface. 4:10 a.m. While the fight on the water continued, a new threat began to appear from below. The Seahawk immediately switched its multimode radar into high-resolution short-range scanning, searching for small objects near the waterline. The sensor started picking up faint metallic signatures just above the churning waves. These were not random reflections. They were the rhythmic signals of Iran's Mersad-class smart mines, advanced seabed weapons designed to react to acoustic and magnetic triggers. The pilot's voice cut through the secure communications channel with emergency priority. The surface swarm is not the only problem. We have an underwater minefield at coordinates 7 Alpha. Hard turn immediately. 4:15 a.m. Inside the Combat Information Center of the Ali Burke-class destroyer, the mood changed instantly. The operation shifted from offense to survival. The captain ordered an emergency stop and commanded a hard turn to starboard. The 9,000-ton destroyer leaned sharply, its hull groaning under the pressure as it narrowly avoided a cluster of mines that could have caused devastating damage. The AN/SQQ-89 system confirmed the danger. The Hormuz passage ahead was heavily mined, while semi-submersible impact craft were closing in from another direction. The destroyer was now caught in a tactical squeeze. If it stayed still to clear the mines, the incoming craft would close the distance. If it moved to evade them, it risked crossing directly into the minefield. 4:20 a.m. This was the final trap. If the U.S. destroyer maneuvered away from the approaching boats, it could strike a hidden mine. If it remained in place to scan and clear the water, it would become an easy target for the next wave of IRGC surface units. The tension on board was almost unbearable as the second wave of the swarm accelerated. Faster, tighter, and more aggressive than the first. These boats were designed to hit ships at the waterline, aiming for the thinner sections of the hull to cause rapid flooding. The U.S. crew was trapped between two threats: the mine-filled water ahead and the incoming swarm behind. They had only seconds to choose between two dangerous options. 4:25 a.m. With the fleet pinned down, the captain of the Arleigh Burke-class destroyer authorized the most powerful non-physical response available: full activation of the ship's electronic warfare system. This was not simple jamming. It was a high-intensity electromagnetic attack. The destroyer's electronic warfare arrays focused a powerful radio frequency beam across the Strait, sweeping through the battlespace with overwhelming force. The effect was immediate. The remaining Ababil decoy drones lost their GPS signals and command links, then began dropping out of formation one by one. The IRGC swarm started to lose coordination. Without central control, the fast boats drifted off course and began colliding in the darkness. Their operators were suddenly blinded by failing navigation screens, which showed nothing but white static. 4:30 a.m. As the electronic interference began to clear, the destroyer tightened its defensive perimeter, preparing for the final wave of close-range contact. Raytheon's Phalanx CIWS, the close-in defense system affectionately nicknamed Hot-Tempered R2D2 by the crew, entered its automatic search and engage cycle. Its onboard radar scanned for any fast-moving object closing in at high speed. The M61A 120mm Vulcan cannon began to spin, sending out a continuous stream of tungsten rounds at an astonishing rate of 4,500 rounds per minute. The night flashed again and again as the system opened up, intercepting the approaching semi-submersible craft less than 500 meters from the ship's hull. 4:35 a.m. At the same time, the 5-inch Mark 45 Mod 4 naval gun at the bow, manufactured by BAE Systems, joined the defense. It began firing airburst rounds equipped with multifunction fuses. Each round was programmed to detonate just above the waterline, scattering a wide cone of fragments across the path of the remaining fast boats. The effect was immediate. The last surface craft that had slipped past the Phalanx system were swept out of formation before they could reach the destroyer. The Strait, only minutes earlier, filled with confusion, high-speed movement, and pressure from every direction, had suddenly gone quiet. What began as a coordinated attempt to overwhelm the U.S. fleet had been broken apart by layered defense, electronic warfare, and precise fire control coordination. The U.S. Navy had not simply endured the blockade. It had taken apart the IRGC's naval strategy, step by step in a matter of minutes. Tehran's greatest advantage, speed, surprise, and numbers, had been neutralized by superior sensor fusion, automated defense systems, and electronic dominance. 4:45 a.m. The battle now changed direction. The Arleigh Burke-class destroyer was no longer reacting to the threat. It was taking control of the fight. High above the battle space, the Boeing P-8A Poseidon used its AN/APY-10 radar to cut through the smoke, spray, and remaining interference. The aircraft began identifying the source of the attack with increasing precision. Concealed missile sites and submarine facilities built deep into the limestone cliffs of Kesham Island. The hidden network that had launched the operation was now exposed. The coordinates were transmitted in real time to the A-10 Warthogs. Moments later, the aircraft circled back for one final pass. This time, they were carrying Raytheon's GBU-12 Paveway 2 laser-guided precision munitions. With the Poseidon feeding targeting data from above, the A-10s released their payloads with pinpoint accuracy. The strikes landed directly at the cave entrances, triggering a powerful chain reaction inside the hidden storage areas. Fuel reserves and military supplies ignited deep within the tunnels, causing the concealed IRGC bunker network to collapse under the weight of the limestone cliffs. The underground complex that had supported the entire operation was gone in seconds, sealed beneath thousands of tons of rock, dust, and shattered concrete. 5 a.m. The blockade had been broken. The Arleigh Burke-class destroyer pushed forward into the main shipping lane, re-establishing control over one of the most important maritime routes on Earth. Behind it lay the remains of an ambitious campaign that had collapsed before sunrise. Tehran's Operation Hormuz Gatekeeper had been dismantled in less than 2 hours. The strategic leverage Iran hoped to gain, the ability to pressure the global oil supply through control of the Strait, disappeared into the morning haze. All that remained was smoke drifting over the water, scattered wreckage, and the ruins of a plan built on overconfidence. But what would have happened if Iran had never launched that reckless swarm operation? If Tehran had chosen a quieter strategy, relying only on hidden mines and low-profile disruption, it might have forced the U.S. into a long and exhausting mine-clearing campaign. The Strait could have remained unstable for weeks, slowing global shipping and sending shockwaves through the world economy. Instead, by choosing open confrontation, the IRGC gave the U.S. Navy exactly what it needed: a visible target, a clear threat, and legal justification to respond with overwhelming precision. Iran did not simply lose a naval engagement, it lost its strongest strategic card in the region. One tactical mistake turned the Strait of Hormuz from a pressure point into a trap. And in less than 2 hours, Tehran's greatest hope for regional dominance was reduced to silence before the sun had even risen.